Tom is today going to present all the latest tech available from NVIDIA to this broadcast and media industry.
So let's talk about the next generation GPUs for virtual production. The next generation GPUs for virtual production are what we call the NVIDIA Blackwell architecture. There are many features that bring virtual production to the next level. This includes new Tensor Core improvements. Tensor Core is the AI processor in the GPU. New NVIDIA encoding, decoding capabilities. We'll talk about those. More memory on the GPU. We'll talk about that. Then combined with that is it also includes a new AI management processor, because in virtual production now we're doing AI to make better pixels that to extend the rendering and extend the performance of the GPU. And at the same time, we're typically doing graphics. So with a management processor, we can reduce the latency of doing AI and graphics together and improve the performance. And they also support PCIe Gen 5, so we have the highest performance when you insert the GPU into your system and build your application around it for virtual production. Yeah, so the flagship of our Blackwell generation GPUs for the professional content creator and for virtual production is what we call the NVIDIA RTX Pro 6000 Blackwell Edition. The idea is to deliver the ultimate performance in a single GPU-like workstation form factor for creative people doing virtual production. So we can get up to 96, because it has GDDR7 memory, which is higher density than previous generations. We could get 96 gigabytes of device memory on the GPU board, right? So you have more memory for AI models, and you have more memory for really complex geometry for virtual production. At the same time, it works at 600 watts, and Kuban loves 600 watt GPUs. More power, the better. It includes both 4 NV encoders and 4 NV decoders. So another part of virtual production is being able to bring video into your virtual set, right? So you want to bring in a video feed, you want to decode it and put it on a quad or put it on a background, and then you want to decode at the same time. So we have 4 of those in the high-end product, and then 4:2 support. In broadcast media entertainment, we were asked to do 4:2 support for encoding and decoding for many years, and we finally deliver it in the Blackwell GPU architecture. Yeah, so for media entertainment workflows, like in virtual production, you could get up to 11 times faster than our previous generation GPUs. So this is all aspects from the editing to the rendering to AI image generation and video editing. All aspects are accelerated 3x to 11x faster on the Blackwell GPUs. Rendering to video, the increased streaming performance with the Blackwell GPUs really makes them shine as well, and makes them the ultimate GPU for virtual production. So you can stream more streams into your virtual production environment. Next slide, please. Yeah, so the RT cores. The RT cores are what do ray tracing. So when the RTX GPUs came out, this is the 3rd generation. We had Ampere, we had Ada, now we have Blackwell. We came up with RTX, ray tracing. So we moved from just doing raster graphics in the GPU to doing ray tracing. So we're kind of on the 4th generation of doing ray tracing on the GPU. And if you know ray tracing, it's shooting light rays into the scene, just like in real life, doing triangle intersection, boundary intersection with the geometry in the scene, and creating ultra realistic imagery for your virtual production set. And in the past, we accelerated the triangle intersection and boundary box intersection, but with Blackwell, we add additional features where we can do accelerated ray tracing, ray intersection with clusters of triangles, and in those triangles, they may not move between one frame to the next, so we can take that geometry and we can encode it, and then we can use it in the next frame again, instead of having to redo all the calculations of the ray boundary boxing. And then moving on to AI, what's happened is the models keep getting bigger and bigger, and when they get bigger, they take up more memory, and there's also more parameters to do the AI. And what's happening is they're getting so big that they don't run on new GPUs. So what we came up with was FP4, which is a new way to encode the model so that it takes up way less memory. So with the 5th generation tensor cores that do the AI processing, the multiply and accumulate that's done in AI inferencing and training, we can, compared to FP16 and our previous generation GPUs using FP4 in Blackwell, we can save 2x, we can reduce the memory footprint of a model by 2x, and we can double the performance. So the AI within your virtual production set, it can be twice as fast. Moving on.
Yes, we are really happy. I've seen the 6000 Pro that you have sent us, one of the first samples. We just plugged it in. We looked to the performance and we have watched all the performance improvements that you have explained. It's great. And in the previous generations, we didn't have the Pro series available with uncapped power, let's say. I love 600 watts of GPUs, but it required a new factory and cooling design from you. So we appreciate the design. It's very, very efficient. It's very powerful. Although it fits into 2 slots, it's a different design. The hot air doesn't go from rear of the chassis. So the hot air goes into the chassis. So we had to isolate the CPU's air intake and the GPU exhaust. And once we made all the airflow work and the power delivery, we made the power delivery sure that it delivers the 600 watts over the 12 volt high power connector very stably. We have seen great stability and performance compared to previous gen. Yes, we have watched that. It's a big improvement, especially if you compare this with the previous ADA generation GPU, which only had the 300 watt blower form factor. We appreciate that NVIDIA now uncapped the GPU and available for us with all of its power with the new thermal design. And this is like, for example, to give you an example, the set that we are running here is using Unreal 5, and we are able to render it in Ultra HD with all the luminant stuff, all the ray tracing stuff in Unreal 5. We do all the video I/O, keying, compositing in the GPU, and we still have at Ultra HD 60p, we still have 20-25% of headroom left for extra performance. So it delivers Ultra HD virtual studio with lumen rendering, with all the other things, plus some more headroom.
That's awesome.
This is much more than we expected. So the 600 watt version of the Blackwell, we are really, really happy with the results we got from it. And we are designing a special platform for that to handle the GPU's thermals and electrical requirements so that we can have a stable, usable product by our customers as well.
Cool.